Guys, it's Nicholas 2.0 Random here. Right now we're gonna be reacting to what if Earth got kicked out of its orbit by In a Nutshell. Okay, just wait. But anyways, let's get into the video.
The night sky seems peaceful and orderly.
Yeah, the sky is beautiful indeed. But actually, it's very hostile.
But in reality, stars are careening through the galaxy at speeds of hundreds of thousands of kilometers per hour. Not bound by static formations, but changing neighborhoods constantly. Fortunately, space is big, and so the stars are...
Yeah, space is a huge place that we are very far away from everything.
The Milky Way are very unlikely to hit us. Unfortunately, they don't have to hit anything to make us have a really bad time on Earth.
How?
And there are already stars starting to get very close.
And also, is that a monkey holding a cell phone? Come on now.
To understand how dangerous stars are to us, we need to talk about gravity. Gravity attracts...
Yeah, gravity is basically something pulls down to its orbit. For example, Earth pulls a meteor down into its orbit because it's much bigger than the meteor. Basically, the bigger the object, the more gravity it has.
Every piece of matter to every other piece of matter in the universe. You are attracted by an atom a million light years away and vice versa. Luckily, this force gets weaker over distance, and it also depends on how massive something is. So things that are close and are very massive are more attractive, winning the cosmic tug of war. This way, massive things define how smaller things behave around them. The Sun makes up 99.75% of all the mass in the solar system, and so it shapes the behavior and orbits of everything else.
Yeah, the Sun is so big, not even everything in the solar system combined can outsize the Sun.
In it. Billions of years ago, after the Sun was born, the solar system was a chaotic and dangerous place as the planets were formed from countless little pieces that collided constantly. But over the eons, a stable balance emerged. Today, most planets and asteroids have settled into safe and predictable orbits. We have the inner and outer planets, the asteroid and Kuiper belt, and at
Yep, we already know this.
the edge, the Oort cloud, a giant sphere of comets orbiting slowly in cold storage. We really don't want this balance to be disturbed. If another star came too close to us, its gravity would pull on everything in the solar system like a spoiled toddler, messing up the pleasant order of the planets and asteroids and...
Yeah, because the gravity of the star actually pulls everything into its orbit, I guess tossing things all over the place and eventually destroying the entire solar system.
comets. This isn't some imaginary danger. Some 70,000 years ago, a red dwarf, brown dwarf binary system passed through the Oort cloud and messed things up. It might even have sent a deadly onslaught of asteroids our way.
Wait, so you're telling me that a star come to the solar system billions of years ago? What?
But it could take 2 million years until those visitors from the Oort cloud arrive in the inner solar system. But there's a much bigger problem on the horizon. Gliese 710, a red dwarf with about half the mass of the Sun, is currently headed towards the solar system. In about 1 million years, it'll...
Well, looks like we have something to worry about. A red dwarf star coming to the solar system. Great.
pass through the Oort cloud and become the brightest star in the night sky. A close flyby like this would unfold over hundreds of thousands of years, disrupting the orbits of millions of objects in the Oort cloud considerably. If we're unlucky, it will trigger a new period of planetary bombardment similar to the early solar system. The night sky could be filled with comets and asteroids raining down on the inner solar system. The larger ones could cause dinosaur-level mass extinctions and would be bad for the stock market. But it could get much worse. The galaxy is an intense place, and stars get close to each other regularly. So it is possible that a star could come much closer and not just pass us, but fly directly through the inner solar system. This would be very bad in the extreme.
Basically, I think it will probably just throw Earth into a deadly orbit, or like throw Earth to the sun or very close to the sun, like Mercury or Venus, or toss it like very far beyond the solar system, like a rogue planet.
The chance of another star colliding with the sun is astronomically unlikely, but that isn't what we're worried about. If another star were to pass by about as close as the Earth is from the sun, it could easily eject the Earth from the solar system. The odds of such an event are estimated to be around 1 in 100,000 in the next 5 billion years.
Whoa.
Small, but not absurdly so. As we discussed in another video, there seem to be billions of rogue planets doing their own thing in the galaxy, and this is one way to make them. So if this were to happen with an average red dwarf, what would happen on Earth? Kicking Earth out of the solar system.
Yep, Earth. It's time for Earth to become a dwarf. A rogue planet.
As the star enters the solar system, a small orangish dot appears in the sky that grows bigger and bigger for months, eventually becoming visible during the day. It would get bigger and much brighter than the moon. Too bright to look at directly. The night sky would be filled with an eerie red glow. After a few months, it would start shrinking again.
Whoa.
But so would the sun. Over a few years, the sun slowly grows smaller in the sky, and with it warmth and light start to dissipate. All around the world, as the days turn dark, the final winter of humanity would begin. The polar ice
Eventually, this point, everything and everyone would die at this level.
caps begin to grow and spread, while plants shrivel and die. Forests freeze, and animals die in droves. As the Earth passes the orbit of Mars, the average surface temperature has plummeted to near minus 50 degrees Celsius. From space, Earth begins to look like an icy moon, the blue-green surface becoming the pale grey-white of death. As global infrastructure breaks down, people huddle together indoors, burning what they can for warmth as the temperature continues to drop, counting the days until they'll be out of food, which no longer...
Yeah, because since that we will no longer get sunlight, we will no longer have food, have plant anything to eat, basically. We cannot grow plants because there will be no photosynthesis, and also all the animals could have died at this point because they have nothing to eat at this level.
grows. Everybody living at the surface is living on borrowed time. By the time Earth reaches Jupiter's orbit, surface temperatures sink to minus 150 degrees Celsius, lower than the coldest ever recorded temperatures in Antarctica. Needless to say, by now, almost everyone is dead. Without the energy from sunlight to evaporate water, clouds don't form and the water cycle stops. The polar ice caps eventually touch at the equator and the oceans become covered in a thick layer of ice. As more and more of its heat leaks out, more water freezes onto the bottom of the ice sheet, the concentration of salt in the deep ocean grows, poisoning most animals that survived here. Although around hydrothermal vents, communities of extremophiles might adapt even to these circumstances. Deep below the surface, some bacteria would not notice much of any of this, as they're still kept warm by the radioactive decay of elements.
Oh yeah, the Earth's core. Basically, if you guys don't know this, I react to a video about life on rogue planets. Basically, the core of the rogue planet actually continues to heat up, and also animal creatures that live down very, very deep into the ocean will not even notice anything because they're getting heat from the core of the planet.
The Earth's core. As the Earth reaches the orbit of Pluto and the Kuiper Belt, the Sun is still the brightest star in the sky, but it's one among many, with stars now visible during the day. The temperature is now barely 40 degrees Celsius above absolute zero, below the freezing temperature of the gases in the atmosphere. A weird spectacle, enjoyed by no one unfortunately, unfolds as the atmosphere turns into nitrogen and then oxygen snow. Over a few years, it's deposited into an icy 10-meter thick sheet all over the planet's surface, with only a thin whisper of gas remaining. The frozen corpses of flora and fauna are buried beneath them. As Earth leaves the solar system, it becomes a rogue planet, traveling alone through the dark, lifeless and in solitude. But weirdly enough, there is hope. Humanity would not be surprised.
How is there any hope? The sun, there's no more sunlight and we cannot get any resources. It's completely over for everyone and everything in on the planet.
By this potential extinction event, we'd notice it thousands of years in advance. There's not a lot we could do to stop a star, but we could prepare. Most of us would perish, but a few million could survive in huge artificial complexes powered by geothermal and nuclear energy, possibly even fusion if we can learn to use the ice around us for power. Here,
how can we even use ice as power? What is this?
Humanity might survive for hundreds of thousands of years. At some point, we would become used to our circumstances, and new generations would watch documentaries in disbelief about the time we had our own star and could walk the surface of Earth. And at some point, we might decide to look for another home. If the Earth were lucky enough to pass by another star with a habitable planet, we could try to make a fresh start. Spaceflight, oddly enough, would become very easy without the atmosphere in the way. So it's not unthinkable that the last survivors would leave Earth behind and try again on a new planet around a
when Earth get pulled to the star system,
new star. Maybe one day, thousands of years later, the descendants of humanity will tell legends about Earth's ancient past. Stories of our lost home, of a mysterious icy planet, floating alone and empty through the dark of space. So basically, the key to humanity's survival is learning about what we'll be dealing with.
Anyways, that's gonna be the end of this video, and I'm gonna be skipping the rest of this stuff, and I'll be seeing all of you in the next video. Bye.